let's begin. Multi-file projects. So far, we've been looking at toy programs that for the most part fit in a single file, but complex C programs are made up of many files that are all compiled and linked together into a single executable. In this chapter, we'll check out some of the common patterns and practices for putting together larger projects. Includes and function prototypes. A really common situation is that some of your functions are defined in one file and you want to call them from another. This actually works out of the box with a warning. Let's first try it and then look at the right way to fix the warning. To compile them, you need to specify all the sources on the command line. Output file, source files. In that example, foo.c and bar.c get built into executable named foo. For these examples, we'll put the file name as the first comment in the source. Let's take a look at the source file bar.c and file.c with the main in it. Right, now see how from main we call add, but add is in a completely different source file. It's in bar.c while the call to it is in foo.c. If we build this with gcc-o, we get this error, implicit declaration of function add in serial line 9, or you might get a warning, which you should not ignore. Never ignore warnings in C. Address them all. Okay, that's a good tip. Yeah, don't ignore warnings in C. Address them all. So I wonder why he started with this first. For a moment, I was thinking that he wouldn't talk about the source files, but he does. So let's create the source files first. foo.c. Right. So this is foo.c. Right. So hash include. I mean, obviously it doesn't work because the compiler doesn't know what the hell is what is a printf. It doesn't know what add function is, right? Because the declaration of add function and all is in the definition of add function is in the bar.c. Return x plus y. See how from main say we call add, but add is in a completely different source file. It's in bar.c while the call it is in now -o foo.c bar.c, and there you go, implicit declaration of function add. We get this error. If you recall from the section on prototypes, implicit declarations are banned in modern C and there's no legitimate reason to introduce them into new code. We should fix it. What implicit declaration means that is that we are using a function, namely add in this case, without letting C know anything about it ahead of time. C wants to know what it returns, what type it takes as arguments, and things such as that. We saw how to fix that earlier with the function prototype. Indeed, if we add one of those to foo.c before we make the call, everything works well. No more error, but that's a pain. Needing to type in the prototype every time you want to use a function. I mean, we used printf right there and didn't need to type in a prototype. What gives? What? Oh shit. Yeah, that makes sense. Yeah. So one way to rectify that error is do this, obviously add intended. You don't have to write the keywords, not keywords, the parameter names. I always thought you had to do that. How much is my charge? Yeah, my charge is half. Oh, hey. So yeah, -o foo.c and bar.c. There you go. The thing is, no, that is not what I wanted. Oh, foo. 5. There you go. But that's a pain. Needing to type in the prototype every time you want to use a function. I mean, we used printf right there and didn't need to type in a prototype. What gives? We actually did include the prototype for printf. It's in the file studio.h and we included that in hash include. Can we do the same with our add function? Make a prototype for it and put it in a header file? Sure. Header files in C have a .h extension by convention, and they often but not always have the same name as their corresponding .c file. So let's make a bar.h file for our bar.c file and we'll stick the prototype in it. So bar.c, oh wait, no, bar.h, int add and int int boom and may not main foo.c, and I believe it's going to be a hash including thing here. Hash include, there you go, hash include. Now let's modify it to include that file. Assuming it's in the same directory, we'll include it inside double quotes as opposed to angle brackets. Oh yeah, bar.h dash o foo. I mean, I don't have to do this. Foo.c bar.c and do that. There you go. Clear. There you go. Notice how we don't have the prototype in foo.c anymore. We include it from bar.h. Now any file that wants that add functionality can just include bar.h to get it, and you don't need to worry about typing in the function prototype. As you might have guessed, hash include literally includes the named file right there in your source code, just as if you typed it in. And building and running, indeed we get the result 2 plus 3, yeah. But don't grab open your ring of choice quite yet. We're almost there. There's just one more piece of boilerplate we have to add. Dealing with repeated includes. It's not uncommon that a header file will itself hash include other headers needed for the functionality of its corresponding C files. I mean, why not? And it could be that you have a header hash include D multiple times from different places. Maybe that's not a problem, but maybe it will cause compiler errors, and we can't control how many places hash include it. Even worse, we might get into a crazy situation where header a.h includes header b.h and b.h includes a.h. It's an include infinite cycle. Trying to build such a thing gives an error. Nested depth 200 exceeds m1x7 Maybe it could have resolved the cycle on 200 first step. What we need to do is make it so that if a file gets included once, subsequent includes for that file are ignored. The stuff that we are about to do is so common that you should just automatically do it every time you make a header file. And the common way to do this is with a preprocessor variable that we set the first time we hash include the file. And then for subsequent hash includes, we first check to make sure that the variable isn't defined. For that variable name, it's super common to take the name of the header file like bar.h, make it uppercase, and replace the period with an underscore. So put a check at the very top of the file where you see if it's already been included, and effectively comment the whole thing out of it has. If bar, don't put a leading underscore because a leading underscore followed by a capital letter is reserved, or a double leading underscore because that's also reserved. Okay, so if ndf bar slash h, if bar isn't defined, define bar, define it with no particular value, file bar.h, hash ndif, end of the intent diff. This will automatically cause the header file to be included only a single time, no matter how many places try to hash include it. I didn't understand any part of that. So dealing with repeated includes. It's not uncommon that a header file will itself include other headers needed for the functionality of its corresponding C files. Great. I mean, why not? And it could be that you have a header hash included, a header hash included multiple times from different places. Or it could be that you have a header hash included multiple times from different places. Maybe that's not a problem, but maybe it would cause compilers. And we can't control how many places hash included. Now, even worse, we might get into a crazy situation where a.h includes header b.h and b.h includes a.h. It's an include infinite cycle. Trying to build such a thing gives an error. Maybe it would have been resolved the cycle on the 201st step. What we need to do is make it so that if a file gets included once, subsequent includes for that file are ignored. So isn't that bad? I don't know. Is that bad? Professionals out there, please do comment in the section below. I mean, whoever knows the answer. Isn't that like, if you can only include one file, then you can't include that file itself to another file, right? So that's bad, right? I want that file for multiple. What if I need the file for multiple things? I don't know. Maybe to resolve the cycle on the 201st step, what we need to do is make it so that if a file gets included once, subsequent includes for that file are ignored. The stuff that we are able to do is so common that you should just automatically do it every time you make a header file. And the common way to do this is with a preprocessor variable that we set the first time we hash include the file. And then for subsequent hash includes, we first check to make sure that the variable isn't defined. For that variable name, it's super common to take the name of the header file like bar.h, make it uppercase and replace the period with an underscore. So put a check at the very top of the file where you see if it's already been included and effectively comment the whole thing out if it has. Oh, very top when you see if it's already been included and effectively comment. So put a check at the very top of the file where you see if it's already been included and effectively comment the whole thing out if it has. Yeah. So let's see nvim bar.h Boomi, right? Hash if and def, right? Bar h, and then hash define bar h, no particular value, and then hash end if. Wait, show me that again. Fuck. nvim bar.h. Okay, good. Now, yeah, had to be included only a single time, no matter how many places try to hash include it. Only a single time. Gotcha. cc foo.c bar.c 5. Okay. So what I want to try is hi.c. I'm gonna hash include the bar.h, and then yeah, what if I just do this? cc hi.c foo.c and bar.c. Okay, I don't know whatever happened. Okay, if you guys have any answers to that, like why would that be necessary? I mean, I guess not to cause any like include, but yeah, I still don't get what it is. Static and extern. You can refer to objects in other files with extern. You can make sure file scope variables and functions are not visible from other source files, even if extern is used with a static keyword. For more information, check out the section in the book on the static and extern storage classifiers. Isn't this in the other, the before one where the storage class specifiers are there? Isn't this? Yeah, this is in the thing. I wonder, he did say he's gonna explain this more, right? Oh, I'm forgetting something. Yeah, I know what static and extern does. Extern is for to get stuff. Yeah, you can refer to objects in other files with extern, and static is that it's the file only available to the file itself. Now, comparing with object file. This isn't part of the spec, but it's 99.999% common in the C world. You can compile C files into intermediate representations called object files. You can compile C files into intermediate representation called object files. These hold the machine code, that is ones and zeros of the actual instructions that haven't been built into an executable yet. Object files in Windows have a.object extension. In Unix likes they are a.o. In GCC we can build some like this with a C compile only flag. Oh, gcc -c foo.c. Oh, look at that, foo.o. And then we can link those together into a single executable. Voila, we produce an executable file from the two object files. But you're thinking, why bother? Why can't we just do kill two balls with one stone? Voids. I read it at balls. For little programs, that's fine. I do it all the time. But for larger programs, we can take advantage of the fact that compiling from source to object files is relatively slow and linking together a bunch of object files is relatively fast. This really shows with the make utility that only rebuilds sources that are newer than their outputs. Let's say you had 1,000 C files. You could compile them all to object files to start slowly and then compile all those object files in an executable fast. Now say you modify just one of those C files, C source file. Here's the magic. You only have to rebuild that one object file for that source file and then you rebuild the executable fast. All the other C files don't have to be touched. In other words, by only rebuilding the object files we cut down on compilation times radically, unless of course you are doing a clean build, in which case all object files have to be created. So that was a short article. That was a very short article, not gonna lie. Multi-file projects, and I learned a thing or two, includes and function prototypes, and why would we do what is -c compile only flag and -o and extends. But I still haven't gotten this part, like why only do #1 include. About the next article. So our next article is going to be the outside environment, And yeah, I hope to, this was a very short video, it's because of the short content, but yeah, I don't care, let's stick to the program, one article per video. So see you next time, bye.